So let's take a look at expressions with rational exponents and radicals. So now when you have exponents, they're not going to always be whole numbers or integers. Sometimes they're going to be fractions, and so those are rational numbers. So as an example, if you have like n to the 2/3 power, your exponent is a fraction or a rational number, or something like, let's say 6 to the 1/2 power. That is an exponent that is rational. Also, we have the radical symbol here. And some people know it as the square root symbol, but it's actually called a radical symbol, and that is used to indicate roots. And an expression that contains the radical symbol is called a radical expression. And so the number underneath the radical sign is called the radicand, and the number in front of your radical sign is called the index. So an expression with a rational exponent or fractional exponent can be expressed as a radical expression or vice versa. So if we see here, these items below, we have x to the a over b power. So here that is a fraction. And to rewrite it as a radical expression, we would simply take our numerator or our top number and move it to underneath the radicand or underneath the radical. And so that would be my exponent here. And then my denominator, b, would be actually my index on the outside or in front of the radical. So let's take a look at some examples here. We have the rational exponents. We want to convert them to a radical expression. So if we look at example 1, we have x to the 3/4 power. We could say that my 3 is a and my 4 is b. And then I would just use my information at the top here to rewrite it. So my b, or my denominator, would be 4, which would be my index. I bring over my base, so that would be the radicand. And then my top number, which is 3, would be under the radical. So let me rewrite that a little neater. So that would be x to the 3rd underneath the radical, and then my 4 would be in the front because that would be my 4th root. If we look at example 2, we have 5 to the 1/2 times 5 to the 1/3 power. So we first want to combine since we have the same base. And you have to remember your exponent rules. So now since we're multiplying and we have the same base, we want to add our exponents. So that is your exponent rule. Okay. All right, so we want to add 1/2 and 1/3. So I'm just going to do some work down here. So 1/2 plus 1/3, because I have to add those fractions. They don't have the same denominator, right? Well, my least common denominator would be 6. So just adding fractions as we normally would by finding the least common denominator. All right. And then I ask myself, 2 times what will give me 6? 2 times 3 will give me 6. So I can rewrite 1/2 as 3/6. And 3 times what is 6? 3 times 2 is 6. So I can rewrite 1/3 as 2/6. And when I add them, I get 5/6. So that is my new exponent. So that would be 5 to the 5/6 power. Rewriting that as a radical expression. My 6 would be my index, so that will go on the outside or in front of my radical. And that 5 to the 5th will go at the bottom. All right. Looking at example 3 here. Again, I want to start out by just writing my radical symbol. M is my base. So again, 6 is at the bottom, so that goes in front. My 1 is at the top. There's an understood 1 here, so we don't put 1. So just like if you have any variable, there's an understood 1 in front. There's also an understood 1 for your exponent, so we don't put a 1 here. All right, we don't put it there. I'm just going to erase that. So we will leave that as just m, and it is understood that that would be m to the 1st power. So that is my final answer here. If we look at number 4, I have a 3 n to the 2/5 power. The 2/5 is the exponent for the n. So I'm simply going to bring over my 3. And then I need to rewrite this n to the 2/5 power with the radical. So once again, that 5 is my index. So that goes in front of my radical. N is my base. And then 2 would be my exponent underneath the radical. And let me just write that a little neater. So that would be 3 times the 5th root of n to the 2nd power. Alright, so I have rewritten all of these expressions using a radical. Alright, so before we move on, we need to review properties of exponents. So some prereq skills here that hopefully you already are familiar with or that you already know. So with our exponent, anything to the first power is always just that base. So a to the first is just, of course, a, or like 2 to the first is just 2. Remember, if you have a negative power, we flip the sign of the exponent and flip the base. Power of 0, anything to the 0 power is always 1. So a to the 0 power is 1. Power of a product, so if you're multiplying and you have the same base, you're simply going to add your exponents here. Power of a power, so if you have a base with the exponent raised to another exponent, you are multiplying, so keep the base and multiply the exponents. And lastly, here we have the power of quotient, and of course, since we're dividing, we would subtract our exponents. So remember, if you're multiplying, you're adding your exponents, dividing, subtract your exponents, and then here, exponent raised to another exponent, you're going to multiply them. Okay, so now we have some problems that we're going to actually do the reverse. So we have radical expressions and we want to convert them to rational exponents. And so with the first one here, example 5, I always start out by writing my base. My base is 8. And I like to just remember that the number in front of my radical is the index, or it's going to be the denominator of my fraction. So if you just remember that one piece, you know that, okay, whatever number this is at the top, or this is in my numerator. So my expression is 8 to the 3/4 power, and that is it. All right, let's take a look at example 6 here. We have x to the 2/5. So we have a fraction underneath the radical. So we have to do something with that fraction and this 3 to simplify it first. Now please note that if you have any number in front of your radical sign, that is the index, and we could call that the root. And so as an example, I could rewrite this as x to the 1/3. If I had 4 for my index, I could rewrite this as x to the 1/4. All right. So if you have a 3 or a cube here, or any number, you can rewrite it as a fraction with 1 being in your numerator. So one more, if I have a 5 here, I can rewrite that as x to the 1/5. All right, so hopefully you get the pattern here. So let's rewrite this first. So I'm going to bring over my x to the 2/5, right? Because that 2/5 is already the exponent for x. But I can rewrite this exponent, or this index 3, as 1/3, because that's really to the 1/3 power. I'm using this here. So we have to have some prior knowledge of the power rule, which is one of your exponent rules. The power rule tells us to multiply these two exponents. So if you have an exponent raised to another exponent, you will simply just multiply them. So I'm going to do that. My base is x. 2/5 times 1/3 is 2/15. And that is my answer. I have rewritten that radical expression as a rational, with rational exponents. All right, so we're just going to try a few more before you try some on your own. And so if you remember previously, if we have a number in front of our radical, we could rewrite that as a fraction, so that would be t to the 1/5. So if you don't have a number right here, it is an understood 1, and so that would be t to the 1/5 power, or the 5th root. Right here, remember, this is the same as raising your term to the 1/3 power, because I have that 3rd root there. So I'm going to rewrite everything and raise everything to the 1/3 power. All right, so I have to apply it to everything, including the 4. So that 4 has an exponent of 1. Remember, we don't put 1 for the exponent. All right, so I'm going to multiply 1 times 1/3, and that's just 1/3. So I have 4 to the 1/3 power. Now I'm applying that 1/3 to the x to the 6. So that would be x raised to the 6 times 1/3. So I'm multiplying all of my exponents here. And then I have y to the 7 times 1/3. So I'm multiplying all of my exponents by 1/3, again, because when you have an index of 3, that is the same as raising it to the 1/3 power. So now I'm just going to simplify here. 4 to the 1/3, I leave that because I don't have anything else to multiply. X, 6 times 1/3, so that's 6 over 1 times 1 over 3. So 6 times 1 is 1. 1 times 3 is 3, and that reduces to 2. So that would be x to the 2nd power. And then 7 over 1 times 1/3, that would be 7 over 3. So I just bring that down. I cannot reduce it, so I just leave it as 7 over 3. And that is my final answer. I've just rewritten this expression with rational exponents. All right, looking at this last one right here, I have the square root of g. If you don't see a number in front of your radical, it is an understood 2, meaning that you're raising it to the 1/2 power. So I simply rewrite this as g to the 1/2. All right, so a helpful hint if you're taking the square root of anything, so just some side information. If I have the square root of 9, that is 3. And that would be the same thing as taking 9 to the 1, or raising 9 to the 1/2 power. That is still 3. So when you're taking the square root of something, you're really raising it to the 1/2 power. All right, so that is how I'm able to rewrite this g to the 1/2 power. Again, that is an understood 2 in front of your radical if you do not see it. So g to the 1/2 power. So here I actually want you to try this problem on your own. So go ahead and give the video a pause and see if you can match up all the problems in column A with the Roman numerals in column B. So go ahead and pause the video and try to match these up. All right, so go ahead and check your answers. Hopefully you got them all correct, putting the correct Roman numeral next to the appropriate expression. So let's try a few more. So in this chart, we're given an expression. In the second column, we want to write an equivalent expression with rational exponents, or exponents that are fractions, and then an equivalent expression in radical form. So I'm going to do the first two, and I'd like to have you try the last two here. So the first thing we need to do is remember the power of power rule to distribute this 1/5 through. So we need to multiply our exponents. So that would be m to the 0, because anything times 0 is just 0, right? And then 2 times 1/5 is 2/5. All right. Now we have to use the 0 power rule. Anything to the 0 power is 1. So I'm not going to actually put the 1. Well, I'll put the 1. So that'll be 1n to the 2/5 power. And then to simplify it even more, I'm going to get rid of that 1 because that is an understood 1 in front of the n if you don't see it. So the final rational expression is just n to the 2/5 power. All right. And I want to rewrite this in radical form. So remember, your denominator is your index, which will go on the outside here in front of my radical. N is my base. And that 2 would be my power or my exponent underneath the radical. So I've rewritten this problem as with rational exponents and an expression with in radical form. So let's look at this second one here, right? So I have my radical symbols here. The first thing I want to do is rewrite these in rational form. So I'm going to actually write it right here. That's going to be 4 to the 1/4. So remember, 4th root, same as raising it to the 1/4. Then next I have 3rd roots. That will be 4 to the 1/3 power. All right. So now, since I have the same base, I can use my product rule by adding my exponents. So 1/4. So I'm just doing some work down here. 1/4 plus 1/3. Least common denominator. So just simple adding fractions, finding my least common denominator. 4 times what is 12? 4 times 3 is 12. So I can rewrite 1/4 as 3 over 12. And I can rewrite 1/3 as 4 over 12. So I'm simply just adding fractions. So no extra rules here. Just your basic finding a least common denominator and adding your fractions that just happen to be exponents. All right. So 3/12 plus 4/12 will give me 7/12. So that is my fraction. So my final answer here, I'm just using a different color to distinguish my work. My final answer is 4 to the 7/12 power. So I've rewritten this problem using a rational exponent. And now let's change it to radical form. Okay, again, index is 12, goes in front. 4 is my base. And 7 is my exponent under the radical. All right. So I've rewritten these two problems using rational exponents and using radical form. Now I would like for you to actually try the last two problems on your own. So go ahead and pause the video and try the last two problems on your own. All right, go ahead and check your answers. Hopefully you pause the video and tried the last two here. And so check your answers for both rational and radical form for each problem. And I hope you got these answers correct. All right, so we've reached the end of our lesson here. I want to thank you for learning with me. If you like, please comment, like, share, and subscribe. Some related videos are simplifying radical expressions and analyzing rational and irrational numbers. And once again, I want to thank you for learning with me.